afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel, Accelerating AI Readiness, Scaling Quality with Data and AI Observability, brought to you by our friends at Monte Carlo. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world to discuss how data teams can develop a robust AI readiness strategy by leveraging data, system, and AI model observability to enhance quality and maximize ROI. As enterprises increasingly integrate AI into their operations, the challenge of ensuring data quality at scale has never been more critical. Today, we'll learn how observability practices can proactively detect anomalies, maintain data integrity, and streamline AI deployment, ensuring that AI-driven initiatives deliver consistent and trustworthy results. We're honored to hear from a distinguished pair of experts today: Shane Murray, Field CTO at Monte Carlo, and Michael Segner, Product Marketing Manager at Monte Carlo. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features in the right sidebar. We'll be addressing your questions throughout the webinar, so be sure to upvote the questions you'd like the speakers to address. If you're wondering where your organization stands compared to others on your AI journey, check out the poll question in the right sidebar. And finally, to learn more about how to leverage data and AI observability, check out the call to action below throughout the webinar from our sponsor, Monte Carlo. Now, without further ado, I'm excited to welcome our speakers to the stage, Shane and Michael, and I'll turn things over to you guys. Welcome.
Hey, thanks, Brian. Thanks for having us. All right. And thank you all for being with us. We're here today to talk about accelerating AI readiness, how you can scale quality with data and AI observability. What exactly does it mean to be AI ready? And what are actual strategies and tactics that teams are using to become AI ready with their data today? I'm Michael Segner. I've had the chance to talk with hundreds of data teams about their AI and data quality and reliability related strategies. Excited to share some of those insights with you today. I'm joined by my colleague, Shane Murray, who is our field CTO at Monte Carlo. Before that, he had a life as a senior vice president data platform at the New York Times. So really excited to be here with you today. This is a live webinar. We're live, you're live, so let's make sure we're engaging. Put those questions in the chat. We're going to try to address them as we go along as much as we can. I think we're actually going to start with a poll, if we can pop that up on screen, about AI readiness. Hello, Amelia. Thanks for joining the chat. All right, so how is your team ensuring AI readiness? Go ahead and vote in that poll. We'll look at it in a second. Maybe while you're doing that, maybe in the chat, in a simple sentence, right? Maybe what are some of the challenges that your team is facing as it relates to AI readiness and your data, right? We want to make sure we're hitting exactly some of those challenges as we go along. So we'll just pause for a moment here. All right, and as those results are coming in, maybe what we can do is start talking a little bit about Monte Carlo and introduce us. So we are the leader in data and AI observability. That is a category that has evolved from the data observability category we created in 2019. And we've been growing very quickly ever since. And I think a big reason for that is we introduced this modern approach to data and AI reliability. And so what data and AI observability is, what that approach really centers on is this idea that you cannot use pre-existing explicit expectations of the data. You cannot just do data testing to understand your issues. You need to scale with anomaly detection, understand where those issues might be, and then trace them back to the root cause so you can understand what went wrong and how to fix it before it impacts your business, or before it impacts the trust. As we make these data and AI products more valuable, the converse of that, right, is that the downtime is more costly. And so we've been really fortunate to be able to drive a reduction in that data and AI downtime by about 80% for many of the customers you see on screen today. So we're kind of excited to share this approach and how it is applicable to AI-ready data. In terms of what we are here today to talk about is this idea that we have these really powerful AI models, these really powerful LLMs, but everybody has access to them, right? They are not going to be what drives your unique value. They are not going to be what is the ultimate disruptor in the enterprise. If we look at the quote we have here from JP Morgan Chase, our chief data analytics officer, they're a very forward-thinking company. They are already using Gen AI to inform their agents to interact with customers that are calling into the bank for customer support. So the Wall Street Journal, sorry, Shane, asked our CDAO here, well, you're really committed to this. What models are you building? How are you going to be doing this? And she responded, we're not going to be spending a lot of time building out AI models. It's not how we're going to differentiate ourselves. The secret sauce for us is our data. It's our information. It's not just AI. It's data and AI. And if you think about it, that is what is going to be the real big differentiator, and how we augment and fine tune these models and these AI agents to have that competitive differentiation. Because we know if you think about taking an intern and stuffing them in a closet, giving them no access to any systems or information, AI agents, AI systems are the same way. If they're not informed, they're not as powerful as they could be, right? If we're being able to augment them with that first party data. And, maybe like our intern in the closet, if they don't have that context, they have a tendency to make it up, hallucinate. So how can we kind of combat that with the ability to augment and not just have AI, not just have data, but data and AI together? When we talk to data leaders, Shane and I have a lot of conversations with data leaders. What we find out in our surveys is that 100% have a strategic priority to do AI, right? I think if we look in the chat, we'd probably see something very similar. I'm curious for the folks that are listening today, like, do you have a strategic priority to do AI today? Right in the chat, if you want, just go ahead and put yes or no. 91% currently building an AI product. Many have moved into production already. And okay, great. I can see in the chat from Scott Evans and Bavish, we already have some people who are currently right now having a strategic priority or in production. That's great to see. I'd be curious from the folks who have answered already, how many of you don't think your data is AI ready, right? You have this priority, but you're a little bit worried about the data on the back end, right? Maybe there's this rush to AI, but are we skipping some steps in terms of our AI readiness? Are our different sources in a central place of truth? Is it reliable? How confident do we feel in our ability to inform these AI agents of our first party data, right? If in the, again, in the chat, is anyone, part of the 68%, right? And so I think, we're going to have Shane talk a little bit more about why this might be the case. Why are we doing this strategic AI priority? Why are teams maybe really struggling with AI ready data? What does that mean and how can we get there? So yeah, Shane, let's hand it off to you.
Thank you, Michael. And it's great to be here. As Michael mentioned, I'm Shane. I've previously led data teams at the New York Times. I led a group of about 150 there. I've now been with Monte Carlo for a number of years, both working on supporting customers to roll out data observability solutions, but also now I'm having a lot of conversations with teams around the AI products they're building and how we can directly support the reliability of those great products. And so I'm going to talk through a little bit about how and why the landscape has changed, and then how we think of what is a leading solution in this space to ensure quality, reliability of these applications that you're all building. Okay, so I think I mentioned the data landscape has changed, and what do I mean by that? So a couple of things. One is that data has consistently over the past decade moved from being something that was very kind of batch processed BI back office type work. Ensuring reliability was, or it was more about actually ensuring the quality of, say, a BI report at a point in time, to in the last decade, I think we've seen a lot of data teams, I'm sure many of you on the call or on the webinar, invest in machine learning solutions, invest in customer-facing data applications, and now invest in kind of leading edge AI and generative AI applications. And so that those use cases that really require a much higher degree of reliability. And when I say reliability, I'm talking about both the quality of that application that you're putting in the hands of users, and also the kind of consistent performance or uptime of that application. It's much more of an engineering problem than data was a decade ago. I think the second trend is just the increased complexity behind the scenes in both tooling, in the various workflows that support data, and even in the interrelationship between teams that are working on data problems. I'm sure many of you oversee data analytics teams, data engineering teams, analytics engineering teams, data science and machine learning teams, and all of these are part of a data workflow, and even your software engineering teams that are are very often the kind of responsible parties for producing data at the source. And, the problem is that historical data quality solutions, often lacked repeatability, required, data stewards or data analysts or data engineers to write and thousands of, labor intensive rules and still have fairly spotty coverage. And then it was often very hard to triage and troubleshoot these solutions because you had any number of breaks in the chain that could happen that existed across many handoffs. And the result was that stakeholders didn't really have a shared view of where problems originate and tend to engage in kind of tedious debugging and sometimes even finger pointing. So what's the various ways or how do we pinpoint the issues and where data can break? I think I'll start with the data itself. So on the left here, you kind of have a source database. Now this might be either structured or unstructured data. It might come from an internal team or a third-party team, some data provider that you're heavily reliant on. And, we all know the various problems that can happen with this data. There could be a schema change related to a new product release. There could be null or incomplete data coming in. And what we've seen as teams are investing in AI is you now have a multitude more problems where, you're attempting to put into use unstructured data. And, in talking to many data leaders, I think there's questions about, is my unstructured data representative of the things that people are querying these AI applications for? Is it up to date or is it getting stale? How do I ensure the underlying quality of that unstructured data that my AI solutions will rely upon? Let's go to the second point, which is a systems failure. I'd say, from my experience, there are no systems that haven't failed at some point or at some scale. And so very often you could consider these things like orchestrators or ETL solutions, tools like Airflow and dbt, but also in the AI world, you have a new set of orchestrators here, tools like LangChain and LangGraph that have to contribute to this end-to-end system working so that your consumers, whether they're external consumers or internal, get a consistently reliable data product in their hands. And so, what happens when these fail is the data might be late, the data might be incomplete, or the end application might be completely unavailable. Let's go to code changes. So the third problem we tend to see is a code change. Maybe this is a bad SQL join, a pretty common way that the code can break. But in the AI world, this could be a bad prompt, or this could mean that being a model update on the back end and you're actually seeing unintended consequences from in the code and a change in the model code. And so this is just another place that data can break along this chain and result in data that's not fit for purpose. And
Yeah, I'm reminded, Shane, of a conversation you had recently where one of the data teams we were speaking to was talking about not just the code being fragile, not just the systems being fragile, but when you have different prompts with different models, the fragility between the two, right? And so, not just all of these being issues, but all these dependencies across them, it just creates this exponential complexity.
100%. And I think, the thing with AI applications in production and even these complex multi-agent systems is that one code change can have kind of disastrous effects down this chain. And let's go to the final thing. So, even if you get the right data and your code is buttoned up and your systems are working fine, very often you can still see responses that aren't fit for purpose for your user base. A low acceptance rate or, potentially hallucination is probably a common problem that people have encountered in this space, which can sometimes be tied to that input data and can other times be actually tied to the model itself.
I remember one specific use case, Shane. We were talking to an insurance company, and they were ranking the satisfaction of different customer call support transcripts, and they had one of their LLMs rank a customer support call as the customer was 120% satisfied, right? So these data issues can be introduced even by the models themselves as those outputs, right?
So where do we come in, and where does observability come in, more broadly? I think, what's happened with the AI landscape is we've added complexity to this picture. We have RAG pipelines, and we often call out RAG pipelines because I think what we're seeing is that some of these leading applications, it's not enough to rely on the LLM itself. As Michael said at the top of the discussion, this has become somewhat commoditized. What makes these things really powerful is the data that's fed into them. And so we're certainly seeing a common pattern amongst customers that they're investing in these RAG pipelines. But you also have prompt engineering, you have fine tuning, you have various complexity of agent architectures, more models, more systems, more code, more data feeding these. And the challenge remains that all of these four things can break: the data, the system, the code, and the model. And you can't really just write a rule to catch each type of anomaly. You need to have this observability over the system, and you need to be able to find when data breaks, but then you need to actually be able to pinpoint where it is you have to fix that data along this chain.
I think this is really tough for data teams too, Shane, because not only are we kind of merging together these ecosystems and having complexity squared, but if we think about it, we're bringing in so much more data than we were previously. All this unstructured data that now is becoming structured, coming into our warehouse, it creates more volume and more complexity. And that's a double whammy that a lot of teams are facing and trying to struggle with as they think about, like, all right, how do we get AI ready when I'm being overwhelmed by all this new types of data, just volumes I haven't had to deal with in the past.
I think that's the thing I'm seeing a lot with customers that are on the forefront of this is they're building these applications, but they don't yet know what they look like at true scale. Often they're starting with an internal prototype that they'll eventually get to a customer-facing prototype. And as that scales, it's scaling on a lot of unstructured data that hasn't had many eyes on it to date, right? And is kind of been sitting in a lake and hasn't really been used. And so there's a lot of figuring out the reliability problems they'll have, but also kind of preparing that data for the inevitable scale.
Yeah. And I think we had a comment here from Kashal, and I apologize if I didn't get the name right, but the idea is like that he makes, I think is a good one, is that for AI to provide these insights to end users, that data needs to be structured to query and get results back. And if that data isn't available, well, then, that's just one break in the system. So we talked about kind of that bad data at the very beginning. And so just making sure that, both the data and the metadata are there as you're scaling up, it becomes such a critical part of this puzzle. So yeah, I think a really good insight from Kashal there.
Yeah, I'll just say, I mean, that's a great point, and it certainly comes up across any customer I speak to that, they've AI readiness for them used to be about democratizing data through business intelligence. And
Right.
now they're facing this concept of putting an LLM or putting an AI query engine on top of their data and allowing any product manager, marketer, executive to query that data. And the question of whether their data is ready is very often no, it's not ready for that sort of querying at scale. And so what they have to do is, and I think Krishal's pointing to a lot of the things here, they need observability on the data. They need to ensure they have consistent metadata and complete metadata across this system. And they also need to ensure they don't have, 5 different definitions for a page view, right? They need to make sure these LLMs can actually navigate through the semantics of their data and the definitions.
That's such a great point, Shane. Like, I think we've mainly been talking about this from the quality lens and all the breaks that can happen in the system. But to even have the privilege of getting there, you have to have this central source of truth, probably in the cloud. You have to have that semantic layer. So a lot of pieces kind of go into AI ready. Any other points we want to make on AI and data observability here in terms of, like, we kind of really have defined the problem set. Maybe a little bit about how we've seen some of the data teams we talked to like really start thinking about how to solve it.
Yeah, and I think we can also maybe touch on some of the things that we're seeing in observability that you need to do to up-level your game in terms of the way we're using AI in the product.
All right, great. Let's do that.
Okay. So this is one thing we're seeing is that data teams are being pushed to find more productivity, to be more effective, and you're managing the ways that your data can be exposed in many more ways and needs to have what I'd say is engineering levels of reliability and also a level of quality that's fit for the purpose of that eventual use case or the many eventual use cases that being used for. What we've seen for us is that means actually investing in a few technologies. One we're calling the monitoring agent, right? And you can think of this as a way to kind of supercharge the data steward or the person that would be writing kind of quality rules for your organization. And so what this monitoring agent does is it actually recommends rules and thresholds and creates them with a click of a button. So typically this is something that a data steward or domain expert had to do. The agent actually mimics that process by looking at the data, the metadata, the descriptions, and then actually analyzing samples of that data to come up with a useful rule to apply to your data set. And so the idea being it actually condenses that process of monitor creation from maybe weeks down to minutes, and also allows you to reduce coverage gaps across your data. So this is something that we've seen both be kind of a practical application for how you make your data more reliable, but also reduce one of those arduous tasks that falls to domain experts in the business.
And that's just so critical because, as you said, as we were just talking about, Shane, like there's this volume of data that's coming in, the surface area is expanded. If we don't expand our monitoring strategies and our ability to scale, then those are going to end up being blind spots. Curious, when you're talking about setting these rules and monitors, what exactly, like what types of issues are we talking about?
Well, I'll use an example from a Major League Baseball team because I think it's hopefully one that's relatable to people. But you can think of various dependencies in your data that are actually hard to articulate in terms of business requirements. And Major League Baseball teams tend to have a table, and let's just kind of talk in a flat table structure, a table for every pitch that's being pitched in a Major League Baseball season. And what we've been able to do is have LLMs automatically create a rule that says, say, a fastball should be between certain speeds and a curveball should be between certain speeds. And these are validations that can ensure that that data is actually getting processed reliably. That's a very kind of niche use case, but I think you can also think of how that sort of automation applies across financial data or commerce data or web and app kind of data where there's intricate relationships between how people use the product and kind of the attributes of their usage.
I love that, right? So we start with like the basics of like freshness. Did the data come in on time? Was the right volume? Is there schema change that's going to break our pipelines? What are those metrics of quality that we expect? So we can start there. We can set, define parameters if we want. We can look at the trends historically using anomaly detection if it's just different than it normally is. And then we have the ability to use Gen AI to look at the fields, to look at the metadata description, to look at how it's being used in query code and understand some of these really complex multi-field relationships. And you put it all together and you have something that I think to Kshal's question, how do you solve DQ quickly and consistently? Well, you use AI, you automate, you do some of these things. So yeah, I think that this is really interesting. All right, let's go on to the next one here.
Yeah, so the next part in observability process, obviously those monitors help you catch incidents or potential incidents. And once you identify that you have a critical data incident that's affecting downtime, when I was a data leader, this was actually the hardest part. I would often have to put multiple teams onto trying to find the root cause of an issue because we didn't know whose data it was in and who had the expertise to actually find the problem. I think this is something that many large organizations struggle with, is how you effectively find the root cause in a short period of time so that you can ensure that reliability and you can bring your data back online and avoid this downtime. And so the troubleshooting agent here is something that helps you triage and resolve when incidents occur. And so you can think of the engineer process, or both analysts and engineers, what they would do is test different hypotheses. Is it a data problem? Is it a problem at the source? Is it a problem in recent code changes? Are any of our systems broken? Is there issue with the model that we're applying to this data? And then they would look to aggregate those results and try to find out which of these was coincident with the incident. And so what the troubleshooting agent does is, starts with one table and then works recursively back to check all the tables upstream, essentially leveraging hundreds of LLMs in parallel in under a minute to test these various hypotheses. So the idea is that it's replicating that human approach, but at far greater efficiency and in less time.
Yeah, it's really interesting. If we think about what we were talking about earlier, right? The root causes of this bad data, right? So not just the 6 dimensions of data quality, but the 3 or 4 root causes. Having a sub agent being able to look at, the metadata of the different systems. Did we have an Airflow DAG failure? Looking at all the pull requests you mentioned, Shane, having an agent specifically go through that. Looking at all the tables recursively to try to identify that point of origin for that bad data. And then really having an agent that governs it all, gets all the hypotheses, get all the information that would have taken 18 hours or more otherwise, and instantly having an explanation or a point to start, right? For the people who are on the front lines troubleshooting these issues. Really powerful efficiency here. I did want to ask you a question from Kashal. He asked about the monitoring agent and that what we were presenting. Is it readily available? Or is the idea that you need to create the utility and have access to metadata, and so that the data stewards can create rules and execute implementing on that underlying data?
Yeah, so this is something that's readily available today, and actually, for us, this is being used across hundreds of customers. And there's actually a stat there on the slide, I think, or maybe it's not on the slide, but we're actually seeing a 60% acceptance rate in these AI generated rules for monitoring your data. So I'd give that a tick in terms of success, in terms of how we're helping these teams define the rules to monitor their data.
And then the troubleshooting agent in terms of where that is today.
So this is one that's in beta. So we've launched this to a few customers, but it's actually in the next quarter we plan to release it much more widely.
Yes, and I think we actually got a really great question from, and again, I apologize if I don't get the name right, Hidri at FedEx, who was asking for an example where the troubleshooting agent was used. I think the question might be around this 80% reduction in time to resolve incidents. And so as Shane was talking about, this is currently in beta. We have had some examples where we've used this with one Fortune 500 CPG company. But as I said, it's in beta. And so where we're kind of getting some of these stats is it's really we are already doing a lot of this automation in terms of tracing these issues back to the root cause in the platform currently and the results that we see from customers. And so the idea that we're going to be able to replicate that even more is what you're seeing here, if that answers that question. So today, Monte Carlo does trace the data and quality issues back to the root cause. And in the future, we're not going to just be doing that with AI and some rules. We'll be doing this with troubleshooting agents as well. And they'll add explainability to it. I'm sorry, go ahead, Shane.
I was just going to add the other thing that the leading teams we work with do is they measure these critical metrics associated with incident resolution. So how long does it take them to detect an incident? What's the median time to detect? What's the median time to resolve an incident? And these are things that teams have operational dashboards to give feedback on. All right, for the last month, we're actually resolving an incident in 10 hours, right? And so they can actually see when they have this reduction in time through a lot of these dashboards that are tied to their alert and incident volume.
It's a great point, Shane. And these were questions and challenges you were tackling in the New York Times as well.
Yeah, For sure. There's also a question from Kushal around, are the utilities developed today for a certain functional area, or is it generic? I believe it might be the former, as you're talking about beta version. So it's a really good question. These are generally available, and what we find is that across the Monte Carlo customer base, which includes automotive companies, e-commerce companies, financial institutions, media companies, technology companies. There's a vast array of companies and use cases where this is applied. I'd say sometimes monitoring is what gets the most domain specific, and you may need to still build, if you're in financial services, some very precise specific monitors using SQL or another coding language. But the actual incident resolution process, we find that this data systems code model approach is very comprehensive in finding the source of any major issue that's affecting reliability.
100%. And I think you said it very well, Shane. I think to Shane's point that there's going to be certain metrics that are universal, right? Nulls are generally never a good idea, but there are always going to be kind of specific business outcomes and business logic and metrics that you're going to want to define for yourself. And then on the resolution side, on the root cause analysis side, a lot of teams have kind of standardized around a specific stack. I don't think we were going to necessarily get into it today, but since we did get a couple of questions on it, if you think about the modern data stack, you have your typical ingestion tools, your transformation tools, your data warehouses, data lakes, and you have your Snowflake, Databricks, BigQuery, Redshift, a lot of these tools serving as the foundation for a lot of teams. And so those systems all perform in a very similar way. And so by Monte Carlo being integrated and unifying those signals, it allows us to do this very horizontally. So really great questions from the audience, really insightful questions. We can tell we got some really some good practitioners here today.
The other thing I might just add to Kushal's question is, like, often what I find is that another differentiator is like what level of reliability or quality is important, right? And so you can have financial level accuracy. So many teams we work with have financial pipelines. They have to report out quarterly. They have to have precision within, a penny of the general ledger on whatever cadence they're reporting. So that is a case of very high degree of accuracy or quality on the data. And then you have some pipelines that might be used for, say, content recommendations, which have to be very responsive and fast, but maybe the level of precision on that data can be a bit lower based on the use case. And so I think it's both a challenge, but part of the role of data teams is to define that level of reliability that suits each use case and ensure that for their customers.
I was at that reminds me, Shane, I was at the Gartner Data Analytics Summit a couple of weeks ago. I was talking with a lot of different data teams that were trying to understand and think about, like, how do you measure data quality? How do you measure data reliability? And I think the point you made is a really good one, in that data quality is almost always specific to the use case, right? You brought up two examples of where those requirements for specific data products or data and AI products would be different, right? And so you want to build the data quality requirements to the use case. You don't want to overbuild, right? Because that's just overhead. But then on the other hand, you have these operational response metrics, which can be a little bit more standardized, right? Time to response, time to fix. That can be, doesn't have to be use case specific. You can have that on data and AI products a little bit more upstream, right? Before they become use case specific, on tables that are upstream, maybe in that raw or silver layer. And then you can have it more on that downstream gold layer as well. And I think, to your point, Shane, what we see a lot of teams doing is maybe starting to tier those out, right? This is our certified data. This has a priority response versus something that might not be used every day. I know you've talked with some teams about this too.
Sure. Yeah. We have a question I'll pose to you, Michael, from Hridi Kulkarni. We currently use Databricks for troubleshooting issues. When will the MC Databricks support be available for end users? Thanks again.
Awesome question. And the answer, I think, if I understand, if I don't, please clarify, is today, right? So Databricks is a priority partner of ours as a tier 1 platform. So in terms of observability for Databricks, like, let's go through, what we've been talking about, the data systems code and models, right? So as Monte Carlo will have visibility into those Databricks workflows, those orchestration systems as that data is coming in. Or if maybe you're using Airflow to orchestrate some of those systems, we'll have visibility there. And oftentimes your data story doesn't just start in Databricks, right? It could be in a transactional database, could be in S3. So being able to not just have that Databricks lineage, which we can inherit from Databricks, but having that cross-system lineage across, showing you that whole system too as well, right? And then let's talk about the code that we talked about, right? Like a pull request could go wrong. So we now have insight into Databricks query logs, which is really great. Now we have that insight into what transformations in Databricks SQL Warehouse could have, made this data go awry. And so these are within the last year or so. And what's really great is just being able to provide that insight across, the Databricks workflow, right? And then also, again, down to the BI level, right? So yeah, I think the answer is today, if that answers the question. Anything you'd add to that, Shane?
No, I just add, there's a bunch of new features in Databricks around both. You may have seen the AI BI solution, which is one we're supporting in Monte Carlo, and then there's also AI workflows that people are building within Databricks, which is a focus area for us too.
Yeah, Databricks is a great partner. We're talking with those product teams probably every other week. So yeah, great question. And yeah, I think Hidri brings up a great point, right? We can see the pain that he's facing, right? Where something breaks and now all of a sudden you're trying to check a bunch of different workflows and you're trying to match like the different failures to the different anomalies that you may have and trying to see which one's which. It's like searching through two different haystacks and then matching the needles together, right? So luckily Monte Carlo will help with that. All right, really great discussion. Please keep the questions coming. We really appreciate them. The other point I think we wanted to talk about was related to, again, data and AI and some of the use cases we're seeing actual teams use. Pilots are a really interesting one that I think a lot of teams can maybe take a cue from. So what they're doing is they are starting to look at the unstructured data they have and starting to think about what are the use cases we can have for it. And so what Pilot is they operate more than 750 truck stops across the country and doing a lot of fuel distribution, right? Gas station. And so there is traditionally just a lot of handwritten notes in terms of gas prices and processing of the prices in the different parts of the country. And what they were able to do is automate being able to extract that previously unstructured information, make sure that it is then structured, and then accelerate their pipelines and their reliability. So now all of a sudden they can monitor those data pipelines. They can trust those outputs. They can start making some more predictions based on that data. And so it's led to millions of dollars in savings in terms of just better financial operations, reconciliation, and starting to move into that predictive realm, which is a game changer there, right? So again, kind of to what Shane and I were talking about a little bit earlier, in that there's a whole new data source that's untapped, and there's a lot of value there. So how as the data teams can we start thinking about that? And then I think Shane also mentioned this RAG use case. It's one we see a lot in Monte Carlo. I think there's probably almost our entire customer base either has one or is moving towards one. And it's this idea that we were talking about at the top in terms of data and AI, right? How can you inform AI? How can you augment AI with data? And Credit Karma is a really early adopter of these RAG processes. So they have a chatbot that's interfacing with customers. They're personalizing offerings to customers, right? This is a new way to interact with customers. This is a new potential revenue stream. And they want to make sure they're offering personalized recommendations, right? If, depending on the certain financial background they have from a customer, they want to make sure that their offerings they're providing are relevant to them. And they want to be able to have a history and knowledge of that customer so that they can engage with them appropriately. Right? If I go to ChatGPT right now, if we all go to ChatGPT right now and type in, "Can you cancel my plane ticket?" ChatGPT is going to say no. It has no idea who you are. It has no idea about your engagement history. It doesn't know anything about customer policy. It can't do anything about it, right? So Credit Karma is empowering this chatbot with that augmented retrieval generation and using Monte Carlo to make sure that that data that is informing this chatbot that's engaging with their customers, it's external facing, making sure that that is all reliable. So I think two really important use cases to consider when we think about AI readiness is both the RAG pipelines, those AI inputs, and then potentially those that unstructured use case as well. Anything you would add to this, Shane?
No, I think you captured it.
Well, I think the last thing we're going to end on, and maybe we can have that call to the ebook that we had earlier, right? Driving data strategy in the AI era. We had a little pop-up there. So hopefully if you found this information helpful, I think you'll find the information in that ebook helpful as well. You can also go to the Monte Carlo website, and we have asked for a demo. You can see that monitoring agent today, right? Put our teams to the test. Say, hey, I want to see that monitoring agent Michael and Shane were talking about. Just go to the website, request demo, and we'll make that happen. The last thing we want to end on, right, is just like the time to act is now, right? We're seeing that the stakes are higher than ever. As data moves beyond these static dashboards to things that are customer facing, to things that are to where we're moving from faster decisions to automated decisions, the bar for reliability is much higher, right? So we've seen, Unity had a, $6-figure, wait, 7-8-figure, 9-figure, $110 million issue, right, with their stock dropping because of reporting bad data to the street, right? Imagine having dozens of AI agents running across your organization without any sense of what's going on, right? Damage could be as much or greater. Citibank, had some U.S. regulators find them for data issues. And then my favorite is the chatbot that agreed to sell a Chevy Tahoe for $1. I think that person earned that Chevy Tahoe through their creativity and their prompt hacking, but not good for Chevy, right? Not good for the dealer that sold them that Tahoe. These are all things where we just want to make sure that we have the right level of reliability in place, make sure that data is AI ready. So I think this is a part where we are going to start to get into maybe some general questions. But before, Shane and I just go back and forth, would love if there's any additional questions from the audience. Maybe we'll take a second to pause, see if there are. Okay, while we wait for some of those questions to come in, we have a few minutes here. Shane, I am definitely curious. I hear the term AI readiness, and part of me kind of is like, oh, we've been there before. You led a team at the New York Times, and you were probably starting to think about AI readiness, but you were thinking of it in the terms of machine learning, right? And how do we get our data ready for machine learning? So I'm curious, like the parallels you see and, some of the steps you were taking at the New York Times that you think might be applicable to, this new wave of Gen AI.
Yeah, good question. I think maybe I'll just say what I think is different today. I kind of mentioned this earlier, but when we talked about kind of readiness for people across the company to have access to data, and I think the term data democratization is fairly common in large organizations. How do you go beyond analysts who are experts in SQL and have access to your curated data, or maybe beyond that, to actually opening it up to product managers, marketers, finance, and other experts around the company who are domain experts but may not be fluent in languages like SQL. And so I think this has just made this data democratization problem much harder for data teams, and means that for data to be ready, anything that you're putting in front of those, text to SQL type query engines has to have a high degree of trust. So people have to know which data to trust. You have to be, I hear a lot of teams, selectively using them on a very narrow slice of data. So you have to know what is your top tier data that you can provide to those sort of engines. How do you ensure you have the metadata across that, so that when there's this natural language to SQL conversion, you don't have things like hallucination in, coming back with a response about the business performance or whatever the query is. And also, I think I mentioned earlier, like strong semantic definitions of your data. So you don't have, a key term for your business, which might be a page view or might be the term revenue. It needs to be defined very clearly so that there's not many different things that an LLM can pick up on as the definition. And then I think the other one is just like a question a lot of data leaders ask, which is like, what does it mean to make my data ready to support, the often what is decentralized building of AI applications and generative AI applications specifically. And so, the best thing you can do is work across the business to understand the use cases that are being built in product teams and are being built in various parts of the business, the data they're going to be consuming, and then think about, all right, how do you apply the same sort of monitoring you've had across structured data to the unstructured data that's feeding these models? And also, we're seeing more of these applications move from, be required to be real time. So how do you ensure that your data environment has this level of reliability, not for slow batch processes, but at any point in time?
I remember talking to you a little bit, and you're a platform guy, right? Like you're always thinking about how to take a pilot, how do we create something that can scale, and how do we like productionize, these pockets of excellence. There's one really great AI or ML application we did here. How do we, I think to use your words, democratize it, right? So I'm curious to your thoughts there.
In terms of scaling a platform to support democratization or to support artificial intelligence?
For all of our folks that have joined us today, right? They might have one AI pilot, maybe a couple. And where I see a lot of these conversations going today is, well, how do I go from one to many? And so I'm just curious for your experience as a leader who's kind of gone through that before. What are kind of this? How do you think about that problem?
Yeah, I think, whether it's been machine learning or AI, there's, you always start with one and you start with a prototype. And I think in talking to a lot of data teams, where I'm seeing the most success is actually starting with an internal AI solution that's consumed by experts. And those experts need to provide human feedback on the system.
Yeah.
It's very hard to go on day one to actually launch this to the public. So you start with expert feedback, then roll it out further internally, and then actually go to external, where you're going to have a higher degree of need for trust in the system, accuracy, and reliability. And so this process of human evaluation that you start with can maybe reduce over time as you build sort of more automated trust in the system. And then I think, just if you're the core data team, how you can kind of get ready for that. I think you have to know within your environment, what is the data that is trustworthy? What are maybe the tiered standards on the data, and what people should be using in these AI products versus what should be, fit for maybe some experimentation and not much more. And then I would be observing or sort of embedding observability in the workflow of these machine learning and AI solutions.
That makes a lot of sense. I think the other thing that comes to mind is it can be a little bit tough, right? And you're in a position where you're not exactly sure which systems might be using, how systems are evolving, what use cases maybe to come out with. You want to make sure that you are not coming out with a use case that might become commoditized by another provider. I'm specifically thinking of these text to SQL asking your own data, right? That we're seeing a lot of platform folks coming out with. How did you focus your teams on, where you could add value versus something that could potentially be either better done by a tool or maybe a use case that might be commoditized by a player in that space that might have a little bit more focus in that area?
Yeah, I mean, I think it's, maybe to answer it with a short answer, it comes down to both what is unique to your business, and then also what is unique and sort of differentiated in your data environment. And so, there's any number of off-the-shelf AI and ML solutions. And I think when you're building data and AI products internally, you need to focus on the areas that are going to be differentiated. So if you're a media company, that's likely something to do with your content data and the behavior of people using your products. If you're a commerce company, you can probably lean into the things about your products and the way people buy those products more than anyone else. And so I just think data teams, especially today, need to kind of lean into what their differentiators are.
Makes a lot of sense. I know you've been talking with a lot of data teams about their Gen AI initiatives that are emerging. Are there, this is a broad question, but are there any general patterns or trends you're seeing that are exciting to you in terms of either how they're thinking about it, what's being developed, or some of the approaches that they're taking?
Yeah, maybe I'd call out a couple. I mean, I think what is super interesting in the conversations I'm having with leading data teams is how many of them are building, internal AI solutions and some of them building external kind of customer facing solutions. But the amount of applications that are either this kind of chat application that can be internal or external, some of those are, become very business critical very fast. And some of them you've got to kind of find the product market fit. But then on the other side, how many people are taking what were kind of very human-centered processes that required a lot of manual work, but repeated work, and looking for ways to do this in a higher productivity sense and faster, which is often some kind of human in the loop solution to the problem that was previously a very manual problem. I think one of the common things I'm seeing across those is this convergence of data and AI. The solutions that are finding the most benefit are the ones that use their data platform, and whether it's Databricks or Snowflake or GCP or AWS, the data that's in their cloud that they can access that's unique to them, and build the AI product with some understanding of their product data, their customer data, their knowledge bases, whatever it may be. That is a very common thread I'm seeing. And then the other is just like how much specialized knowledge is going into figuring out evaluation of this model. Like, what does good look like from a generative AI model? And very often you have to learn that before you can automate it.
Yeah, and no, I think that reflects a lot of conversations you and I have, and maybe we saved the hardest question for last in terms of knowing what good looks like can be really difficult in some of these use cases, particularly around unstructured data. And so, just some of the unique challenges that have kind of come from and approaches that have come from this in terms of evaluations. Curious for your thoughts there.
Unique approaches in terms of
Yeah.
evaluating the output of the model.
Yeah, I know you've mentioned maybe 4 different types of approaches in the past in terms of maybe humans judging, LLMs as judges. And I think you mentioned some teams have looked at business metrics as well, right?
Yeah, I think, a lot of teams will judge the impact of this based on whether it engages their audience more or drives top line revenue from their audience. I think a step back from that is, and similar to the use case we shared about what we've done at Monte Carlo, what's the acceptance rate of, say, a recommendation or a response from these models? How effective are they at delivering on the user's prompt? Is very common kind of automated approach to look at like how successful your model is, the prompt versus the response. And then I haven't seen many teams that aren't doing some form of human evaluation. I think that is critical in these applications to both identify issues in them, and also just kind of learn how it can become a better, and you can iterate into a better model.
I think it's a really great place to end, Shane. I know I appreciate your insights. I think our audience does as well. Maybe a good place to wrap would be just, a recap of all the different things that can go wrong with your data and AI, right? You could have your data, unreliable data sources. You could have your challenging systems. You could have some code issues. You have that model fit for use. And if you are not integrated, if you do not have visibility across all those things and those different ecosystems, then you're not AI ready, right? You cannot trace back your issues back to what caused them, right? It's not just evaluating the output, but being able to have visibility into the machine that generated that output. And so if that is something that might be valuable, check out Monte Carlo. We're a data and AI observability company. We have a lot of thought leadership resources on our blog, whether or not you are interested in a product at the moment. And just start thinking about how do we get visibility into where we need visibility? How do we think about reliability? How are we going to measure it? How are we going to have a really strong incident response? How do we operationalize it? And hopefully some of the answers will be there. So I just like to thank everyone here at Data Science Connect who joined and was with us today and asked so many good questions and engaged with us. Just thank you for your time, and we'll see you on the next one.
Thanks, guys. Really appreciate it. Excellent insights, Shane and Michael. For those of you who missed any of the webinar, if you want to rewatch anything, the recording will be available on this same page. If you just refresh your screen just a couple minutes after this webinar ends, it'll also be on our YouTube channel starting tomorrow. I want to say a special thank you again to our partners at Monte Carlo for making this webinar possible, and we'll see you guys next time. Thanks.